Hello friends, welcome to AI Flux. As of today, Minecraft can be played by AI agents in GPT-4. And this is really cool for a number of reasons. So obviously, many people who watch this channel probably played Minecraft when they were younger. I remember watching the beta come out when I was in high school. And this isn't a spoiler, but what's funny is even the most advanced AI currently available to man still mines in Minecraft in large vertical columns, straight up and down. You'd think AI would have shown us a more interesting way to play in Minecraft, but supposedly the optimal way, or the most likely way by statistics to reach diamond blocks, is just to mine straight down in a vertical column. Now you might wonder, why teach a state-of-the-art AI, let alone a large language model like GPT-4, to play Minecraft? Don't bots already exist to play Minecraft? And how does this bot work? Does it just look at the colors of blocks? We're going to get into all of that, but first let me talk about the model a bit. So this is a project mostly contributed to by researchers at UT Austin and Stanford. A good friend of mine actually did some of the review for this paper, so I thought it was pretty cool to be able to make a video about it. The model itself is called Voyager. Voyager is what they're calling an open-ended embodied agent with large language models. Voyager is the first LLM-powered embodied lifelong learning agent in Minecraft that continuously explores the world, acquires diverse skills, and makes novel discoveries without human intervention. Voyager consists of three components. One, an automatic curriculum that maximizes exploration, and I'll show you what that is in the paper. An ever-growing skill library of executable code for storing and retrieving complex behaviors, which I've not seen before even in some pretty distinguished gaming bots. 3, a new iterative prompting mechanism that incorporates environment feedback, execution errors, and self-verification for program improvement. Voyager interacts with GPT-4 via black box queries, which bypasses the need for model parameter fine-tuning. The skills developed by Voyager are temporally extended, interpretable, and compositional, which compounds the agent's abilities rapidly and alleviates catastrophic forgetting. Empirically, Voyager shows strong in-context lifelong learning capabilities and exhibits exceptional proficiency in playing Minecraft. It obtains 3.3 times more unique items, travels 2.3 times longer distances, and unlocks key tech tree milestones up to 15.3 times faster than prior state-of-the-art bots. Voyager is able to utilize the learned skill library in a new Minecraft world to solve novel tasks from scratch, while other techniques struggle to generalize at all. So this is very cool. What I really like about this is the methods they actually go into in the paper are mostly completely novel. Most of these techniques have not been done before, even in sort of a more conventional sense of machine learning. So some video of this is available. What I think is cool is watching this just looks like a person playing Minecraft. This is actually the bot doing its thing, understanding how to jump on top of blocks, build, etc. And what's interesting is I think this is distinctly better than existing AIs written into Minecraft. It's important to note that AIs in video games are probably the oldest running field of AI research generally. It was the first sort of novel use of AI that passed for sort of a really cool, almost magic feature set in tech. And people might wonder, oh, like, why are PhDs wasting their time training AI agents to play video games? And when you think about it, in terms of a training environment, video games, in terms of their completeness, in terms of their boundaries, and in terms of like discrete tasks, goals, and objectives, are actually a really great existing way to train models, develop models, and measure the effectiveness of models. Because again, like, there are objective goals, there are milestones, and there are very clear limits to an environmental interaction. And yeah, so that's why a bunch of PhDs spent the better part of a year and a half prior to GPT-4 coming out developing this novel approach. So the Hugging Face page is pretty bare. It's basically just the abstract of their paper. And then there's this cool kind of chart outlining prompting iterations that are delineated by what they're calling the Minecraft tech tree. So these are the different tools and implements that the character has and how quickly they achieved them. And the two other models they're comparing to are Voyager without their internal skill library, and then two other game AIs that are called Reflexion and React, which actually focus on the colors of specific pixels. So this is the paper. There's the abstract again, the same chart we saw in Hugging Face. What's interesting here is when they go into how their, what they call curriculum, interactive prompting mechanism, and skill library work. So basically, the automatic curriculum is based on known tasks that are already objectives in the game. So like mine wood, make a crafting table, fight a zombie. So these are essential tasks that basically have to happen for executive function of a player in the game to work at all. So obviously you can't really do anything else with tools. If you don't have a crafting table, you can't build a crafting table without wood. And in order to survive the night, you have to be able to combat zombies. So these are essential tasks that have to happen. And then basically with input from exploration progress, the environment itself, some code they wrote, that's how you end up with this interactive prompting mechanism to then build further skills and then validate them against existing goals. The root of this is proposing suitable tasks, refining a skill. So these are based on environmental feedback, then understanding what a committed mastered skill is and getting that into memory for future reuse. Reuse is the key term here. And then continuing on sort of a generalized task. And what's cool with Minecraft is it's kind of an open world thing, right? So if you wanted to, you could just build axes and mine wood the entire time. You could decide to sleep and never engage zombies, or you could only engage zombies if you really wanted to. And what I find interesting is they're a little vague initially on what automatic curriculum is, but then here they go into how this takes into account the exploration progress and the agent's state, so the player's state, and the curriculum is generated by GPT-4 based on the overarching goal of discovering as many diverse things as possible. Now, what's really cool is here they actually provide some raw examples of what these prompts are. And some of this is vision-based. So for instance, when you see a crafting table, the question is, what is my inventory? So this is the input. Basically, they're just taking raw data from the game saying, I have 3 oak planks, 4 sticks, and 1 table. And then GPT-4 is fed that. And the reasoning that they receive is, since you have a wooden pickaxe and some stones, it would be beneficial to upgrade your pickaxe to a stone pickaxe for better efficiency. And then the secret sauce here is they can turn that into a discrete task, which is something that the agent can actually do, which is craft 1 stone pickaxe. And then this is repeated. So there's one for fishing. There's one for understanding what you can do or what you should do if there's a pig around you based on if you're hungry or if you want to corral it. And then there's some other ones like a reasoning around smelting, reasoning around do I sleep, do I attack zombies, etc. The skill library and the interactive prompting mechanism are probably 2 of the most novel attributes here. And if you want to read through this further, it's really kind of interesting. And I think these papers are the most powerful because if you've played Minecraft, and even if you're kind of a novice developer or you're someone who's just learning, this is actually a really cool way to understand kind of the logical processes that go into these agent-based applications. And I do have an upcoming video on AI agents specifically. So to keep a lookout for that. If you're watching this and a card comes up, it means I've made the video and you should go watch it. So what's really cool here are kind of the 2 linchpins of why any of this works. So they show here an execution error. And here they say they consider error as environmental feedback. So for instance here, the generated code from the last round, environmental feedback, execution errors, and critique, based on which GPT-4 can self-improve, which is something you can do with GPT-4 if you've ever had it do something wrong and then you tell it to fix it. In theory, if you prompt it properly, you can actually have it retain some of that. And in this case, this is done, again, with the agent's state. So this is including inventory, equipment, nearby blocks, entities, etc. And then is largely applied in this kind of chain of thought prompting flow, which basically means that you can build existing memories or known skills into greater chains of thought that result in new skills and means of executing in the environment. So this paper goes on for quite some time. They also have some really cool maps of how much each discovers and explores based on a random generated map. So the other great thing with games is procedurally generated games are actually quite good at generating true entropy and randomness, which is very important in research. And what I think is cool is like they actually chart, how quickly you got to a golden sword, how quickly you got to a lava bucket. And there are a bunch of other really funny examples in here that I highly recommend you guys should look into. The reference section is massive, and if you go long enough, they actually break down the entire algorithm. And I highly recommend you read this if you kind of know Python. This is basically in pseudocode, so it's meant to be readable. It's not real code, so you can't paste it right into anything, but anyone who's done any amount of programming will understand how to actually implement these. So the rest of the paper is just the raw code itself. I highly recommend you guys read through this. I know I'm going to go play some Minecraft tonight. Let me know if this bot progressed faster than you. If you want to see more kind of gaming, paper-related content. And yeah, AI agents are really cool. I think they're a topic that isn't talked about enough. As always, I hope you learned something. If you have any questions about this, let me know, and we'll see you in the next video.